Have you ever wondered what happens inside a Coca-Cola factory before you open an ice-cold bottle? The process is far more complex and surprising than you might imagine. Subscribe, leave a like, and join us till the very end.
Phase 1. Water. The invisible foundation of everything. Before talking about secret formulas, bubbles, or bottles, there is something fundamental that is often overlooked: water. And no, it is not ordinary water. In the production of Coca-Cola, water is literally the backbone of the entire beverage. Without perfectly treated water, the flavor simply would not be the same. Coca-Cola bottling plants use water sourced from local supplies, deep wells, natural springs, or municipal systems. This allows the beverage to be produced in virtually any country in the world. But here is the important part, that water is never used exactly as it arrives. The first phase is an initial filtration that removes large particles such as sand, sediment, or visible mineral residues. It is a basic cleaning step, but necessary to prepare the water for more advanced processes. After that, the water passes through activated carbon filters. This is a key stage, as this type of filtration removes unwanted odors and flavors. The objective is simple but demanding: to achieve completely neutral water, without its own character, aroma, or taste, a true blank canvas. Then comes one of the most important technologies in the process: reverse osmosis. Through special membranes, up to 99% of the remaining impurities are removed, including salts, dissolved minerals, and microorganisms. The result is highly purified water. However, the goal is not to obtain a completely inert liquid. In the final phase of treatment, specific minerals are reintroduced in carefully measured proportions. This adjustment balances the pH and restores a chemical composition suitable for the beverage. The procedure is not random. Each amount is calculated so the water interacts correctly with the other ingredients during mixing. Once this process is completed, the water is no longer intended to be consumed on its own. Instead, it is prepared to serve as the precise base upon which one of the most recognized and widely distributed beverages in the world will be produced. Phase 2. The concentrate. Now we arrive at the point that has sparked curiosity, myths, and theories for decades: the Coca-Cola concentrate. Here we are not going to talk about conspiracies, but about what actually happens inside the factory. The concentrate is a highly controlled mixture of ingredients that defines the final flavor of the beverage. Now, its exact formula remains one of the best protected industrial secrets in the world, known only by a very small group of people. However, that does not mean everything about it is a complete mystery. It is known that the concentrate includes elements such as natural flavors, plant extracts, caffeine, phosphoric acid, caramel coloring, and a special extract from coca leaves that is completely decaffeinated and free of psychoactive components. That last point often raises questions, so it is important to clarify it. There is no cocaine in Coca-Cola. The extract is processed industrially to eliminate any active substance. What remains is a very specific aromatic profile. These ingredients are combined in separate facilities under maximum security conditions. The concentrate is not prepared in the same plants where the beverage is bottled. Instead, it is sent to authorized bottling plants in the form of a base syrup. This system has a major advantage. It guarantees that a Coca-Cola will have the same flavor in different countries, regardless of the local water or the type of packaging used. Once the concentrate arrives at the plant, it is ready to be mixed. And that is where the beverage we all know begins to take shape. Phase 3. Syrup mixing. Once the water has been completely treated and the concentrate has arrived at the bottling plant, one of the most sensitive phases of the entire manufacturing process begins: the preparation of the final syrup that will define the flavor of the beverage. This procedure takes place in large stainless steel tanks designed to guarantee hygienic conditions and uniform mixing inside. The concentrate is combined with purified water and a specific sweetener. The type of sweetener used may vary depending on the region, with cane sugar used in some countries and high fructose corn syrup used in others. Despite this difference, the proportions are carefully adjusted to ensure that the final flavor remains consistent and recognizable anywhere in the world. During this phase, every variable is controlled with extreme precision. The temperature of the liquid, the exact mixing time, the stirring speed, and the balance between sweetness and acidity are critical parameters that are continuously monitored. There is no margin for error, as even a minimal variation could alter the product's sensory profile. Phosphoric acid plays a fundamental role at this point in the process. Its main function is to balance the sweetness of the sweetener and add a slight acidity that contributes to the characteristic refreshing sensation of the beverage, preventing it from becoming excessively sweet. Throughout the mixing process, automated systems constantly analyze the density, color, and chemical composition of the syrup. If any deviation from the established standards is detected, the batch is corrected or discarded. Once the syrup reaches the exact profile, it is cooled and prepared to move on to the next phase of the process, although it still does not contain gas. The final flavor has already been fully defined. Phase 4. Carbonation. One of the most characteristic features of Coca-Cola appears the moment the first sip is taken: its effervescence. That distinctive bubbling is not a minor detail or something that happens by chance. In reality, it is the result of a carefully controlled industrial process known as carbonation, a crucial stage that transforms the liquid into the refreshing beverage recognized by millions of people around the world. Once the syrup has been prepared and precisely adjusted, it is mixed again with purified water. At this stage, the temperature of the liquid is significantly reduced. Cooling is a key step, because carbon dioxide dissolves much more easily in cold liquids than in those at higher temperatures. The colder the liquid, the greater its capacity to retain the gas. After reaching the appropriate temperature, the system introduces carbon dioxide, known as CO2, using equipment designed to operate under controlled pressure. The gas is injected at high pressure into the liquid, allowing it to dissolve within the mixture. Thanks to this procedure, the CO2 remains trapped inside the beverage until the bottle or can is opened. The amount of gas added is not left to chance. Each batch is adjusted according to very precise parameters that determine the exact intensity of the bubbles. If there were too much gas, the beverage could feel excessively sharp on the palate. If there were too little, it would lose much of its refreshing sensation. For this reason, the balance between liquid and gas is carefully calculated. In addition to providing the characteristic effervescence, carbon dioxide also influences the flavor profile. Phase 5. Packaging and sealing. The manufacturing process concludes with one of the most critical phases of the entire production chain: packaging and sealing the finished product. At this stage, the beverage has already been carbonated and has its final flavor profile. So the main objective is to preserve all of its properties intact until the moment of consumption. Coca-Cola bottling plants operate highly automated production lines capable of filling and sealing thousands of bottles and cans per minute. These systems are designed to operate at high speed without compromising precision. Before being filled, each container undergoes a cleaning and internal rinsing process that removes any residue or particles. Afterward, automated inspection systems verify the integrity of each container, detecting possible defects such as cracks, deformations, or impurities. Filling is carried out in fractions of a second, using equipment calibrated with great accuracy to dispense the exact amount of beverage into every container. Immediately afterward, the sealing process takes place, a crucial step for maintaining the internal pressure created by carbon dioxide. An incorrect seal could cause gas loss, affect the product's freshness, or compromise its safety. For this reason, every cap or closure is applied and verified using strict torque and pressure controls. Once sealed, the containers pass through multiple quality control checks. High-speed cameras perform visual inspections, while specialized sensors measure internal pressure and confirm proper airtight sealing. In addition, electronic systems verify the fill level and automatically discard any unit that does not meet the established parameters. After passing these controls, the bottles and cans move on to the labeling stage, where labels are applied with product information, the brand's distinctive design, and the corresponding nutritional data. Later, the containers are grouped, packed, and prepared for distribution. Finally, the product is dispatched through an extensive logistics network that allows it to reach supermarkets, bars, restaurants, and homes in different regions of the world.
Now let me ask you something. Do you prefer Coca-Cola or Pepsi? Let us know in the comments below. Subscribe to the channel and don't forget to leave a like.